Now, those were the examples, simple examples of how it is a complementary situation of when they are always together. Now, we have the concept of circular arrangement, which is just an offshoot of the row type arrangements. Now, in a row, we have the first one, second, third, fourth, and fifth. So, A, you have B. So, first one is the last. Now, when the same thing is arranged this way, you will find that the first one and the last one are one and the same. So, ultimately, the number of n's will always be n minus 1. Always it's going to be. So, suppose there are six people are arranged in a circular manner. One person's position can be kept fixed, and the remaining n minus 1 people would be arranged around him in different ways. You can take any one and the others can be arranged in n minus 1 factorial ways. Two ways of explaining this. One is because the first item and the last item are one and the same in a circular arrangement, which is not true in case of a row type arrangement. Or you can say we can keep one item fixed and keep arranging the various arrangements and keep changing the various arrangements around him, and hence the number of such arrangements will be n minus 1 factorial. So in short, to cut it short, wherever we have a situation of n, the difference between a row type arrangement and a circular arrangement is that the number of arrangements will always be 1 less than n in all ways. So wherever we have an n, we need to subtract 1 in case of a circular arrangement. Wherever we have an n arrangement, number of arrangements in a row type arrangement, the number of circular arrangements will be 1 less than that, simply because the first item and the last item are one and the same. Now this simple logic, how can this simple logic be used to modify the various formulae that we undertook? So let's see these cases. So we have circle versus row arrangement. There's a circle, there's the first one, second one, third one, fourth one, but the first is again the last one. So the first and the last are one and the same. Let's take some examples to understand. Now, n items can be arranged in n ways in a row, understandable. But the same n items, if you start arranging them in a circle, you will be able to arrange them in one way less, because ultimately one person has to be kept fixed and people around him can be arranged in n minus 1 factorial ways. Simple, what I explained earlier. So this is a comparison between a row type arrangement and a circle type arrangements. And of course, this takes into account both the clockwise arrangement and the anti-clockwise arrangement. So we have a simple way of comparing an interesting situation. How many ways 5 people can be arranged in a row? Now, 5 people can be arranged in a row in all the row type of straight arrangements. We know we can be arranging them in 5 ways. That is 5 factorial ways, because n is 5 here. The same 5 people, if you want to arrange in a circle, keeping one of them fixed, it is going to be 5 minus 1 factorial ways. That is, you will be able to arrange these 5 people in 4 factorial ways, not in 5 factorial ways, because the same 5 people are arranged in a circle in 4 factorial ways. So this example, comparative example, will help you understand in what way arrangement in a row is different from the arrangement in a circle. I reiterate, whenever we have n, it is n's value has to be reduced. So, now, for example, here we have a case, number of ways in which 7 girls form a ring. So, 7 girls will form a ring, n is equal to 7. So, the number of ways in which they form a ring is going to be n minus 1 factorial ways. That is 7 minus 1, 6 factorial ways, which is going to be 720. So, among these, the answer is going to be 720. So that is 6 factorial ways.